Hello and welcome to EduSathi. Continuing the topic of algebra, we'll look at the concept of functions. Very important concept from competition exam point of view. Function. What do you understand by function? Function is a relationship between dependent and independent variable. So function is nothing but denotes the kind of relationship that is there between the dependent and the independent variable. The dependent variable is y and the independent variable is x. So y is a function of x. Y is dependent upon x in some way. It could be y is equal to x plus 2. It could be y is equal to x square plus 2. It could be y is equal to x cube plus x square plus 2. Whatever is the relationship, that relationship is a function. Function gives us the relationship between the input, which is your independent variable, and output, which is your dependent variable. Consider the equation y is equal to 4x plus 10. So x here is an independent variable, y is dependent upon the value of x. So if you look here, whatever is your input of x would be multiplied 4 times, then incremented with 10 to give you your output of y. So you give your input of x, it will be done 4 times, then added 10, and what you will get would be y. So x is operated upon to give you an output of y. So if you put the value of x as input as 2, the output you would get would be 8 4 times plus 10, which will be 18, which will be the value of a dependent variable. The other thing that you need to understand is domain of the function. Domain of a function is the range of values of x. That means whatever are the possible value of input variable, or whatever are the possible values of an independent variable, that are termed as domain of this function. The second being the range of the function. Range of the function will be all the values of fx. That means all the set of values of output variable or dependent variable would be termed as range of the function. So independent is domain, or the set of values of input. The set of values of output or the dependent variable would be termed as range. These are very important terms when you are doing your questions on functions. So let's look at an example. The first question that we are going to look at is the question which is a quadratic. Fx is equal to 3x square plus 4x plus 5. X is an integer which belongs to 5 to 0. Find the domain of the function and range of the function. Domain is all the set of input values. Now, if you look at a condition which is there, x could be equal to 1, 2, 3 and 4. So this is your domain. Domain is 4 values, x belongings to 1, 2, 3 and 4. This is what your domain is. Okay. Now if you look at range, range is your set of output values. Now what you do is you put in all the values of input. So that means if you put x is equal to 1, the value that you would get would be 3 plus 4 plus 5. 5 and 4, 9, and 3, what you get is 12. This is the first value of range that you have. If you put your input as 2, so 2 square, 4 into 3, 12, plus 4 into 2, 8, plus 5, which will be 25. If you put the value of input as 3, this will be 27 plus 12 plus 5 that you will have. So if you just keep on finding the values for F3 and F4, all the set of output values would be termed as range, and all the set of input values which are possible for this question would be termed as domain of this equation. Let's move ahead and let's look at another question. Now this question is based upon two dependent variables. So the value of x and y both are independent. Let me call this as z is equal to a function. Z depends upon the values of x and y and was given by this relationship. The question is find the value of f12. That means you have to put the value of x as 1 and y as 2. This will be 1 plus 2 plus 1 cube into 2 plus 2 square into 1 that I will have. So I just keep on adding up the numbers and the answer that I will get would be 9. So the value of f12, that means the output when the input variables are 1 and 2 is given as 9. This is the relationship between the dependent and independent variables. This will be called as a function. Now let's discuss about the various type of functions. The first type is a constant function. Constant function means y is equal to a or fx is equal to a. That means fx will not change depending upon the value of the input. So if your input is 1, your output will be a definite value. If your input is 2, your output will be the same value. If your input is 3, 4, 5, 6, whatever be your input, your output will remain the same. This is how the graph of a constant function fx equals to a looks like. That means if your value of x keeps on changing, the value of y still remains the same. If x is positive or negative, the value of output or y still remains the same. That is what a constant function looks like. The second is identity function. Identity function is also refers to as y is equal to x function. That means if you take your value of input, the same value will actually turn out to be your output as well. So if your input is 1, your output will be 1. If your input is 10, your output will be 10. Your output will be increasing linearly with the input. Why linear? Because the degree of this equation comes out to be 1. So if I plot the graph, this is how the graph of y is equal to fx would look like. So the graph that you will have for y is equal to x is a straight line, is a linear line, because the degree is 1, passing through the origin, making an angle of 45 degrees with the origin, and therefore the slope of this line is 1. The slope of this line is given by tan of 45 degrees, which is 1. Whatever be the value of your input, the same will be the value of your output. So if your input is 1, your output is 1. Input is 2, output is 2. Input is 3, output is 3. Input is 4, your output is 4, and so on. So if your input is negative, your output is also negative. Your input is -2, your output is -2, and so on. This is what an identity function looks like. The slope of an identity function is +1. So that means whatsoever is the change in y coordinate would be same as the change in x coordinates. The third function that we are looking at is an absolute value function or a modulus function. Y or fx is equal to mod of x. Fx is not equal to x, but fx is equal to mod of x. Now what does that mean? If your input is positive, your output would be positive and will have the same value. But if your input turns out to be negative, your output will still be positive with the same magnitude. So if you have y is equal to, your input is 5, your output will be 5. If your input is -5, your output will still be +5. So again, it will be the graph that will be something like y is equal to x in the positive region. But when I come to a negative region, I will not be having y is equal to minus x. It will still be y is equal to x when x is negative. So the graph would look something like this. Here, it's a straight line passing through a region making an angle of 45 degree and is similar to y is equal to x. Here, it is again a straight line passing through region making an angle of 45 degree with the negative direction of x-axis. So the slope of this line would be minus 1, or the equation that will be followed will be y is equal to minus x. So if you remember the graph of y is equal to x, it is shifted up because I cannot have my answer as negative. This is how the graph of y is equal to mod x looks like. So the next type of functions we'll be looking at is polynomial functions. Polynomial functions can be classified as quadratic, cubic, or higher degree functions. Let's look at quadratic first. So the general equation for a quadratic is y is equal to fx equals to x squared. If I plot the graph, this is how the graph of a quadratic function looks like. The functions are defined on the basis of their degree here. So the degree of a cubic function would be a degree 3, and a graph of a cubic function would look something like this. We have done quadratic and cubic in detail in the previous lecture on algebra. So let's move ahead and let's look at rational functions. Rational function is y is equal to 1 by x. So my output would be the reciprocal of my input. The graph of such a function looks like this. As the value of x keeps on increasing, my output will keep on falling. So if my input, I'm talking about the positive one, if x increases, y decreases. And if x in negative decreases, y would increase. So that is the thing that we have. The only thing that you need to remember is the graph. So just remember the graph of y is equal to 1 by x, also known as a rational function or a reciprocal function. The next one is a greatest integer function. For a real number x, denoted by greatest integer function x, the output is the largest integer less than or equal to x. Now let's look at the function. So y is the greatest integer function of x. That means I will exclude the decimal point, and whatever is the largest integer that is contained in the number will be my answer. Let's look at the examples. So for 5.8 would be written as 5 plus 0.8. So the greatest integer function for this would be 5, or I will write it simply as 5. 10, is this 10.0? It will be 10. Now for minus 10, my answer would be different. For minus 10, the greatest integer function would be minus 10. For minus 10.2, it will be minus 11 because it is written as minus 11 plus 0.8. The fractional value or the decimal value can never be negative. It are always to be written as positive, and this is how I will find out the greatest integer function. So for minus 5.8 greatest integer function, the value would be minus 6. For plus 5.8, the value is plus 5. So what you do is, if you know how to represent the numbers on the number line, whatever is the immediate leftmost integer value, that will be your answer. Immediately left integer value is my answer for this greatest integer function. The graph of a greatest integer function looks like this. So for all your input between 0 and 1, my answer would be 0. For 0.9, my answer will be 0. For 0.99, my answer will be 0. But for 1, the answer would be 1. From 1.1, 1.2, 1.3, 1.9, 1.99, the answer still would be 1. But for 2, I will jump to the value which is 2. So it is a stepped function that we have. The next function is the Signum function. The definition of a Signum function is mod x by x. So if the value of mod x is positive, my answer would be 1. If the value of x is 0, it will be 0. And if the value of if the value of x is negative, mod x would be positive, this will be negative, my answer would be minus 1. So the output of a Signum function would either be minus 1, plus 1 or 0. There can be 3 cases only for the output of a Signum function, and therefore the graph of a Signum function looks like this. Y is equal to 1 if x is positive, if my input is positive. Y is equal to minus 1 if your x or your input is negative, and y is equal to 0 if x is equal to 0. The next that we'll be looking at is a stepped function. Stepped function means the function is broken at different points. The definition of a function follows the criteria. The criteria is, if x is less than minus 3, the function would be a quadratic function. If x is between minus 3 and plus 4, it will be a linear function. If x is greater than 4, it will be a exponential function that we'll have. Now these definitions can keep on changing depending upon from question to question. But stepped function refers to a function whose definition keeps on changing depending upon the different input values. Composite function. Consider two functions which are given to you. Fx is 3x plus 5 and gx is 2x square. Then composite function is f of g of x, or we call it as f of gx. That means you first compute this function. The output of this function will act as an input of another function. This is a function inside a function. So if I just have to look at it, the x input will go and we'll be able to find out the function and I'll get a value. Now this output value will act as an input for another function and then I'll get my final value. So this example that I am taking here is fx is equal to 3x plus 5 and gx is equal to 2x square. Now g of f, that means g of fx. First I'll find out the value of fx, then the output of that will be the input of g. So if you look at it, 3x plus 5. Now the value of 3x plus 5, which is the output of x, would be treated as the input for g. What is it? 2 times of x square. So 2 times 3x plus 5 whole square. You solve it out. This will be the value of g of f. I can also find out f of g. That means gx will be an input function. The output of this will act as an input for fx function, which can also be written as f of gx, which will be 3 times. Now instead of x, I'll replace with the value of gx. Wherever is x, I will replace it with gx. Now instead of this x, I'll put the value of gx and I'll write it as 3 times 2x square plus 5. Again, I open this up. This is the value for f of g and this was the value for g of f. This is what a composite function looks like. Composite function is something like you find out the first function, the output of that function serves as an input for another function. Iterative or nested functions. Iterative function means you are performing the same function over and over n number of times. The output of first becomes the input of second, the output of second becomes the input of third, the output of third becomes the input of fourth, and so on. So what you have is the same function being performed over and over again and you get your answer. So let's take an example. The function that we have is 2x minus 1. f4, this 4 means the function has to be performed 4 times. 2, that means the first input has to be 2. So I find out f of 2, which is what? 2 into 2 minus 1. 4 minus 1, which is termed as 3. For the next f, my input will be 3. So it will be 2 into 3 minus 1, which will be 6 minus 1, 5. For the next f, my input will be 5. My output will be 9. For the next f, my input will be 9. My output will be 17 that I have. So if you look here, iterative function means you first find out this, the output of this, input of this, the output of this, input of this, the output of this, input of this. So if you find out, and this value of f(n)x means how many times have you performed the function. So f(3x) means the function is to be performed thrice with the first input as x. f(4x) means the function has to be performed 4 times with the first input as x. In general, f(n)x) would be given by f of n minus 1 x. Now what does that means? Whatever is your output for n minus 1 times, that will be treated as an input for the nth time. The other way we can look at a function is based upon its classification into the first category as odd and even. Odd function. If f of minus x is equal to f of x with a negative sign. So if you find out the value for fx and if you find the value of f of minus x, the value is coming out to be same in magnitude but opposite in sign, that kind of a function is referred to as an odd function. We can take an example of x cube minus x. So if I look at the value of this function, x cube minus x at f as 1. So it will be, let me take at 2. So it will be 2 cube minus 2. So this will be 8 minus 2, which is 6. And if I take at f is equal to minus 2, it will be minus 2 cube minus of minus 2. So minus 2 cube is minus 8 plus 2, which will be minus 6. So if I look at it, my f of 2 and f of minus 2 are similar in magnitude but opposite in sign. Such a function which satisfies this definition is known as an odd function. A thing to remember is odd function is always symmetric around the origin. So if you look at an odd function graph, it will be symmetric around origin. So whatever is the scene in the first quadrant, an image of that will be formed in the third quadrant. Whatever is the graph in the second quadrant, an image of that will be formed in the fourth quadrant. An even function, if you find out the values of f of x and f of minus x, they turn out to be same in magnitude and in sign. So that means you find out the value of fx and you find out the value of f of minus x, they are turning out to be equal. Such a function is known as an even function. Let's take an example. X square plus x. So if you put the value of f2, it will be 4 plus 6, which will be 10. If you take the value of f at minus 2, it will be again 4 plus 6, which will be 10. So f of 2 and f of minus 2 are coming out to be same. Such a function is known as an even function. So even function and all odd functions would be defined by their definition. An even function is a function which is symmetric around y-axis. It has a y-axis of symmetry. That means whatever is in the first quadrant, the image of that will be formed in the second quadrant. So it is symmetric around y-axis. This is symmetric around origin. Very, very important thing from the graph that you can find out. Now, the thing which is important is a function can be neither even nor odd. It is not necessary for a function to be either even or odd. 90% of the functions would be neither even nor odd. Let's look at the second classification. The second classification would be on the basis of domain and range and would be classified as 1-1 function, 1-many function and many-to-one function. We'll just discuss that. So first look at 1-1 function. A function for which every element of range corresponds to exactly one element in the domain. That means for a single input, I have a single output. For every unique value of x, which is the independent variable or an input, I have a single unique value of output as my answer. Let's look at it. This is the values of x and this is the value of y. For every single x, I have a single y as my answer. Such a function is known as 1-1 function. Many function. A function is one to many if there are x values that have more than one y value mapped to them. That means for a single input, for a single x value, there are many values of y. This is how a set would look like. A single value of x results in various values of output. So one value of input gives you many different values of output as your answer. One to many function. And the third one is many to one. That means for many values of input, you have a single value of output as your answer. So for many values of input, you will have single value of output as your answer. This is how it will look like. For many values of input, you will have a single value of output as your answer. So for an element in a range, I have more than one member of domain associated with it. So if this is a domain that you have and a range, for an element in range, you have more than one domain value associated with it. Let's look at the two graphs which are there. If I look at the graph 1 and graph 2 simultaneously, I'll be able to look at and decide that graph 1 is for a 1-1 function. Each value of y corresponds to only one value of x. And if I look at graph 2, it is a many one graph. The value of y corresponds to more than one x value. So this value of y has come from these two different values of x. For this value of y, there are two different values of x that I have. For this value of y, again there are two different values of x that I have. So for this, it's a many one function, and for this value of y, I have only one input. I have only one input for this value of output. Only one input, only one input. So if you look at it, the horizontal line cuts the graph at only one point. Here, the horizontal line cuts the graph at more than one point. So if this thing happens, you can know it's a many one function. This is a property of a 1-1 function. So a function is a 1-1 function if it passes both the vertical line test and the horizontal line test. So horizontal line test is for many one function and a vertical line test is for one to many function. So if I have many values of output for a single value of input, it will be a one many function which will be not passing the vertical line test. So for a 1-1 function, I will have horizontal line as well as a vertical line test passed. 1-1 function is also known as an injective function. So this naming is very important. Another name for a 1-1 function is an injective function. Injective function or a 1-1 function would mean one as the same thing. The other classification of function would be onto function and into function. An onto function or an into function would be explained with the help of the graph. Explained with the help of this sets. So there are various sets that you have. In general, for a different value of input, you have a different value of output. A function is defined as an onto function if for every y in B, that means every output, there is at least one x in the domain. That means for every value in the set of output, there is at least one value which is there in an input, such that fx is equal to y. That means for every output, I should have a defined input. Now if you look at the graphs that are there, you will see that these graphs are the graphs for an onto function. Onto function means for this output, an input is defined. For this output, an input is defined. For this output, obviously there are inputs. For this output, there is an input. For this output, there is an input. For this output, there is an input. For all the outputs that you have an input. But if you look at the last graph, for this output in B, there is no input. A function f is into if there is at least one y in B which is not connected with x in A. So I have an output, but there's no input for it. That is what an into function is. An onto function is a function f is onto if for every y in B there is at least one. At least means there can be one or more. Now I'm not talking about a 1-1 function. I'm talking about an onto function. That means for every y, I may have one or more. For every y, I may have one or more mapping in x, mapping in A. Another name for an onto function is surjective function. Surjective function is another name for an onto function. Now if you look at the last one, this is what an into function is. For a y value in B, there is no x connected to it. So this kind of function would be an into function. Now the next thing is inverse of a function. Inverse of a function means from the value of output, you determine the input. Till the time we were putting in the input and we were getting the output. Now we'll be finding out the input from the output. It's like the reverse that we are doing. So what we are doing is known as inverse of a function. Inverse means if y is equal to fx, then f inverse of x. That means here you put your output variable, you know your output, you fiddle your output, and you will get your input. This is how it is defined, and then we replace x and y. That means again it's just a terminology thing. So let's take an example. The function that we are given is 2x plus 3. The method that we have is write dependent in terms of independent variable, make dependent independent and independent dependent. So what I will do, y minus 3 over 2 would be equal to x. So what I've done is I've made the dependent independent and the independent dependent. Now replace y with x. Y is equal to x minus 3 by 2. Here x actually is the output. It is not the input. And y actually is the input. This has to be taken care of whenever you are writing inverse of a function. Inverse is only possible if a function is 1-1 and onto. So that means the function has to be injective plus surjective. Injective is a 1-1 function. Surjective is an onto function for it to be a bijective function. So injective plus surjective is bijective, and inverse is only possible if it is a bijective function. Inverse means from an output you are able to find input. If it is an onto function, onto means for every output there is an input, and for every output there is only one input, so that there is no ambiguity associated with an input. So there has to be a unique output for every unique input. It has to be a unique case in all these respects. Periodicity of a function. If a function fx repeats its value after a definite increment or a decrement in the value of x, then we say that the function fx is a periodic function. If a function is periodic, then we should have a value p such that f of x plus p is equal to f of fx, or f of x plus p minus fx is equal to 0. Now what does this mean in simple terms is, when you put your input as x, there's some value of output that you are getting. When you increase or decrease your input with a certain value, the value of output starts repeating itself. That is what is known as periodicity of a function. So p here is the minimum possible number after which the function repeats itself.